Oh, you guys are going to love today's assignment. It's word problems. I know many of you love word problems, but sadly, these word problems are rather difficult. So, what I'm going to do is I'm going to do number two completely with you, and then I'm going to help you set up number three, number five, and number six. Let's begin by looking at number two. This problem says 2 times the quantity of 7 less than 1/4 of the number is equal to 4 more than 1/3 of the number. What is the number? So when I do word problems, what I typically like to do is I like to define a variable. I'm going to ask myself, what do I care about? What do I want to know? And that's typically your question. And in our case, the question is, what is the number? So I'm going to define this number with a variable. I'm going to let the letter n represent the number. I'm now going to use this in the rest of the word problem to set up an equation. In this first sentence, when I see the quantity of 7 less than 1/4 of a number, when I say 1/4 of a number, well, that simply just means 1/4 times our number. And when it says 7 less than, well, whenever you see less than, that means you're subtracting. So the piece I underlined in blue is the same thing as 1/4 n, take away 7. And then before that, it said 2 times. Well, everyone knows what 2 times means. That just means to multiply by 2. So I'm going to take my quantity in blue, and I'm just going to multiply it all by 2. And then it says is equal to, well, that's just going to be an equal sign. 4 more than, when I say 4 more than, that means you're adding 4, then 1/3 of the number, which just means 1/3 times our variable, which is n. And once again, let's just break it down one more time to review. It said 2 times, that means we're multiplying by 2. 7 less than meant we're subtracting 7. 1/4 of a number just means 1/4 of our n, which we represented as a number. Is equal to just means an equal sign. 4 more than means to add 4. And 1/3 of the number is simply 1/3 n. Now that we have our equation, we're going to use don't call max after midnight to solve for n. What I like to do before I start solving, I like to draw a line down my middle to kind of tell myself that the left side is separated from the right side. And then we'll begin by distributing. We have 2 times 1/4. Remember, you can make the 2 a fraction by putting it over 1. So we're doing 2 times 1 and 1 times 4. We do the top times the top and the bottom times the bottom. 2 times 1 gives me the 2. 1 times 4 gives me the 4. And then the n you just attach to it and bring it down. Now I'm going to do 2 times -7. 2 times -7 gives me the -14. On the right side, I don't have to distribute, so I just bring it all down. I can now cross off the first step in our list. Now I'm going to check, can I combine like terms? On the left side, I cannot, and on the right side, I cannot, so I can skip that step. Before I move the smaller variable, what I'm actually going to do is I'm going to eliminate the fractions because a lot of us can't add or subtract fractions because we may have forgotten how to. So what I'm going to do instead is I'm going to do a fraction buster. This is going to allow me to eliminate my fractions. The denominators of my fractions are 3 and 4. So I'm going to look at what number do 3 and 4 have in common when I start listing out their multiples. So when I list out the multiples of 3 and when I list out the multiples of 4, what number do you notice that they have in common? You should see that they have 12 in common. So to eliminate the fractions, I'm going to multiply everything by that fraction buster, which will be 12. So basically, we're just going to distribute again. We're going to multiply everything by the 12. 12 times 2/4 is going to be 12 times 2, which is 24. And then 1 times 4, which is just the 4. So 12 times 2/4 is the same thing as 24 over 4. Bring down your n. 12 times the -14 gives me -168. 12 times the 1/3 n gives me 12/3 n. And then 12 times the +4 gives me +48. And then these fractions we can actually simplify. 24 divided by 4, that's simply 6. 12 divided by 3, that's simply 4. So now this problem looks a lot nicer, and it's going to be easier for you guys to do the third step. We can now move the smaller variable. Well, I have a 6 in on the left side and a 4 in on the right side. Obviously, 4 is smaller, so I'm going to get rid of that by subtracting it on both sides. 6 in, take away the 4 in, gives me 2 in left over. The third step is now done. I'm now going to do my adding and subtracting. Well, I have a subtraction of 168, so I'm going to do the opposite. I'm going to add 168 to both sides. And 48 plus 168 gives me 216. The fourth step is now done. And finally, I need to do my multiplication and division. This is multiplying by 2, so the opposite is to divide both sides by 2. And when I do 216 divided by 2, I get 108. So the number that we cared about, what was the number? Turns out the number was 108. And this is your final answer. You typically want to write a sentence at the end of your word problems to make sure you're answering the question. Okay, now let's go ahead and help you set up the other problems. I'm not going to fully solve them like I did for number 2. I kind of want you to do that work. It's going to be difficult for many of us, but remember, we're just looking for effort. It's okay if you get something wrong. Number 3 says Amanda uses a rectangular canvas for a painting. So I'm going to go and draw a rectangle to help me visualize this. The length is 6x minus 3 centimeters. So when we talk about the length, that typically just means the bottom or the top. So the bottom will be 6x minus 3, and the top will be 6x minus 3. And the width is 2x plus 6 centimeters. So that'll be like your sides here, our left and right sides. Those will be 2x minus 6. Or sorry, 2x plus 6. And it also tells us the width is 4/5 of the length. So they tell us the width is 2x plus 6, or you can write it as 4/5 of our length. So I can write it as 4/5 of our length, which was 6x minus 3. What are the dimensions of the canvas? So they're asking you to find the length and the width. Well, you're going to notice something. They wrote the width in 2 different ways, but these represent the same exact thing. So if they represent the same exact thing, we can set them equal to each other. This is the width, and this is the width. This is W, this is W, so we can set them equal to each other. And now you have a problem that you can solve by using Don't Call Max After Midnight. Once you solve for X, you're then going to plug that into your 2 given equations to find the width and the length. When I plug in X into 6x minus 3, that will find me the length. And when I plug in X to 2x plus 6, that will give me the width. So for example, let's say X was 5. If I plug in 5 here, that'll be 6 times 5, which gives me 30. And 30 take away 3 gives me 27. So I would say that the length is 27 centimeters. If I plug in 5 for the width, 2 times 5 gives me 10. 10 plus 6 gives me 16. So I would then say the width is 16 centimeters. So whatever answer you get for X, you're then going to plug into your width and length. Let's look at number 5 now. This one's probably the most challenging one. Eli and Angela are saving money to buy their grandparents an anniversary gift. Eli has saved $8 more than 1/3 of Angela's money. If they each save $10 more, Eli will have saved $4 more than Angela's savings. How much has Eli saved? So I'm going to look at the piece I highlight in blue first, and I'm also going to define some variables. Since I don't know what Eli saved, I'm going to call that E, and I don't know anything about Angela's savings, I'm going to call that A. And now I'm going to look at this first piece in blue. Eli has saved $8 more than, $8 more than means plus 8, 1/3 of Angela's savings. So that means Eli is 1/3 of Angela plus 8. His was 8 more than hers. Now let's look at the sentence in red. If they each save $10 more, Eli will have saved $4 more than Angela's savings. So no matter how much money they added 10 more to it. We now know that Eli's money will be 4 more than Angela's money. So it doesn't matter how much money they have. We always know that Eli's will be 4 more than Angela's. So when I say 4 more, that just means add 4. When I said 8 more, that means add 8. And now you're going to notice something. Both of these equations equal E, or both of these equations equal Eli's savings. Since they're both E, that means we can set them equal to each other. I can set the piece in blue equal to the piece in red. These are both Eli's savings. This is going to then allow me to use don't call max after midnight to solve for A. And once I solve for A, I'm then going to plug it into my equation. I can plug it into the equation in blue or the one in red, but I think this one's going to be a lot easier. I can then plug that in to find the value of E. For example, let's say you find that A equals 2 after using your don't call max after midnight. You would just plug it into this equation. 2 plus 4 gives me 6, so you would say Eli saved $6. Let's say A was 25. You would plug it into this equation. 25 plus 4 would give you 29. So then you would say Eli saved $29. So whatever answer you get at the end, you're going to then plug into this equation to find out what Eli saved. If you want to challenge yourself, you can plug it into the equation on top, the one in blue instead, if you want to make it a little bit harder. And finally, let's look at number 6. This one's also tricky if you don't remember what perimeter stands for. It says the perimeter of the larger rectangle, so that is the rectangle in blue, it's the bigger rectangle on the outside, is 2 meters greater than twice the perimeter of the smaller rectangle, which I highlighted in red. We want to know what the perimeter of the larger rectangle is. So we want to know what the perimeter of the blue rectangle is. Let's go and break down what this says. It says that the perimeter of the larger rectangle is twice the perimeter of the smaller. When I say twice the perimeter, I'm saying you're multiplying it by 2. So we're going to multiply the perimeter of the smaller rectangle by 2. But then it also says it's 2 meters greater. When you say 2 meters greater, that means you're adding 2. So the perimeter of the larger rectangle is 2 meters greater than twice the perimeter of the smaller rectangle. Quite a mouthful, quite difficult to understand if you don't break down the vocab. But hopefully seeing it written this way is a little easier to understand. Now let's go and break down what the perimeter of the larger rectangle is. Well, the perimeter of the larger rectangle will just be when you add up all of the sides. I know the top is 3x minus 1. Well, I also know the bottom is 3x minus 1. Remember, opposite sides of a rectangle measure to be exactly the same. So basically, I have 3x minus 1 2 times. The top and the bottom are both 3x minus 1. And then the left and the right side are both 4x minus 5, so I have that twice. So I'm going to go and distribute the 2. When I distribute the 2, 2 times 3x gives me 6x. 2 times negative 1 gives me negative 2. 2 times 4x gives me 8x, and 2 times negative 5 gives me negative 10. I then can combine like terms. 6x plus 8x gives me 14x, and negative 2 take away 10 gives me negative 12. So we can write the perimeter of the larger rectangle as 14x minus 12. Now let's look at the smaller rectangle. I have x plus 1 on the top and the bottom, so I have it twice, 2 times x plus 1. And then I have x on the left and the right, so this is going to be 2 times x. If I distribute this out, I'm going to do 2 times x to get 2x, 2 times 1 to get 2, bring down my 2x. I'm then going to combine like terms. 2x plus 2x gives me 4x, and then I bring down the plus 2. So I can write the perimeter of the smaller rectangle as 4x plus 2. Now I'm just going to start plugging them into my big equation here. Instead of writing the perimeter of the larger rectangle, I can now plug in 14x minus 12. Instead of writing the perimeter of the smaller rectangle, I can plug in 4x plus 2. So I'm going to plug that in right here. And now you would do don't call max after midnight, and you would solve for x. Once you solve for x, you will then plug it into your equation, 14x minus 12, to find the perimeter of the larger rectangle. So once again, let's say you found that x is 10. You're then going to plug it into the perimeter of the larger rectangle equation, which is right here in blue. 14 times 10 would give you 140, and 140 take away the 12 will give you 128. So you can then say the perimeter of my larger rectangle is 128 meters. Let's say x is, let's go with 5. Well, then I would do 14 times 5, and that will give me 70. And then 70 take away the 12 will give me 58. So then we can say the perimeter of the large rectangle is 58 meters. So once again, this is a very difficult handout. If you get stuff wrong, it's okay. We're just looking for you to try. And I try to set up the harder problems for you. I'm probably didn't explain it the greatest. It's not very easy to explain this over a video because I'm not really sure where you struggle. But hopefully at least watch it a couple times, rewind, and kind of break down what I'm saying, and hopefully in the end it'll make a little more sense.